for the opportunity to share the experience in the sector. Very fortunate to have worked with almost all the water-intensive industries in India and not to mention as well with the government. Good morning, everyone. My name is Anshuman. That was a very long, exhaustive introduction that you gave. Thank you for that, and thank you again for having me here. The topic that we are going to discuss, I believe the focus is on thermal power plants, but being part of TERI, we have had the opportunity of working with several industries and basically with the objective of looking into how we can enhance the water use efficiency. And I can share with you with a lot of pride and let's say satisfaction that by and large what used to be 15, 20 years back, in terms of industrial water use, and I'm talking by and large across the sector, to what it is now, we have really made a very good leap forward in terms of improving the water use efficiency. However, we have enormous amount of opportunity as we move ahead in the future. And that's something that we looked into as an opportunity with various industrial sector. What I'm going to share with you in the thermal power plant is based on our almost continuous water audits of various key power plants across the country, and experiences that we have gathered from other best practices across the world. Also, I have to mention that we just concluded a very key, let's say, important study, which was basically to benchmark water use in water-intensive industries in India, and the objective was to basically it was twofold: to look into what are the key opportunities for water-intensive sectors to indulge into and reduce the specific water consumption, and also what could be that potential benchmarks that can be basically shared with the industries and them to basically follow and reach towards that kind of benchmark. So that's something that we have just concluded, and I'll be sharing largely the perspectives from that. But starting with, of course, the thermal power plant. If you look into, so basically what I'll be doing is just giving you a brief background about the challenges. I believe most of you know all of this, but just to give you a background, then we'll come to the case studies, or let's say the sectoral perspective on power plant water consumption. I'll skip the introduction. If you look into the kind of challenges, we have various kinds of challenges in the water sector. I mean, I don't want to go into too much detail, but I believe you will be all knowing about all this, right from declining per capita water availability to overexploitation of the water, groundwater, inefficiency in almost every sector, be it irrigation, domestic or industrial sector. Then the challenges of climate change, perspective of pollution, etc., etc. All of that is compounding sort of a challenge for any entity to operate and use water for. You have to source water from somewhere and you have to treat it, you have to use it. So all of that factor comes into play together, and we all are facing these kind of challenges since years. That is being done as well, but I believe we still are not there where we should be. Now, one of these interesting questions that we always come across, and this has been continuing since years now, where are we in terms of industrial water use across the country? Now, there are various reports, there are various data. None of them actually are at the national platform in a very combined way to give you a collective picture. We have tried at our level best, to compile some of them, but what is very well known, established, is we still are, less water efficient as far as industry is concerned. We consume more water. Our water productivity is still lower as compared to many others, across the world. Sometime back, the report was around $7.5 per meter cube in terms of productivity. If you compare with other countries, 400, 35, 40, 50, that's the kind of range we are talking about. So we still are to improve on that. And then of course the demand perspectives are increasing over a period of time. The resource is less, or let's say same, but the sectoral water demands are increasing. So how do we meet that unless we go into efficiency improvement, better practices, good technologies, innovations, etc., etc. Now, water sector, power sector, we possibly all of would be knowing that there's a fair bit of wastewater which is being discharged. Thermal power plants are known to consume more water as compared to other countries, and we have had this Ministry of Power, power tariff policy, wherein it was stated that within the 50 kilometer of a power plant, the sewage water, the municipal water, can be used for as a recycle kind of intervention, and that's something which is very welcoming. But also the fact that, there's all that potential which existed in terms of the, treated sewage from the cities near the power plants, we haven't really, utilized that as yet. In terms of percentage, we are fairly low. Now, also, the WRI report long back has told us that, many of the power plants are also in the water stress zone, or the zones where the economic activity are very high, and therefore the demand of water is quite high as well. So all of this is a kind of situation which tells us that we need to be conscious, we need to be efficient in our, water use. Water Mission, I'm sure most of you would know that, had come up with the national water goals. And amongst the 5 goals, one of the goals is basically increasing the water use efficiency by 20%. Now, including aspects related to water audits. So this is something that we focused on, and what we did was we went to the government, and what we shared with them is, why don't we come up with something which can be, setting up a benchmark for the, let's say, water-intensive industries, which can be then, followed, improvised over a period of time, essentially, basically, encouraging the industries to move towards better, targets, and therefore better water use efficiency and better processes. So that's the kind of background that we are talking about. What needs to be done, I think, I've been sharing this since years now. 2 or 3 key interventions. One is we need to reduce our wastages, have resource recovery as well. In today's time, and as of now as I speak, we have demonstrated technologies from the wastewater. You can not only treat and recycle and reuse wastewater, but also generate energy as well as nutrients recovery from within the same. And many of them actually give you a sort of power backup for your own treatment systems. So this is possible as of now, and some of you would know already. We have demonstrated that in Kanpur, Jajmu. There are other examples across, but that's something that is possible. Improving efficiency, no brainer. We have to continue to look into where we can consume less water per unit of product that we are producing. For example, in our case, per megawatt of power generation. And then, of course, interventions related to conservation in every sector, whether it is agri-irrigation, whether it is domestic or industrial. Now, what are the opportunities and the intervention? That's something that I wanted to share with you. And this is the kind of, this is a very comprehensive project that we did almost for over a period of 2-3 years, interacting with almost all the key players in the water intensive sectors. So what we focused was looking into these 4 sectors: power plants, textile, pulp and paper, and iron and steel. And the idea was basically to look into the opportunities, the low-hanging fruits, both short-term and long-term, to look into what kind of water conservation opportunities exist, and based on that, identify where we can reach as a benchmark of water use. So that's the genesis of the entire sort of thought of benchmarking the water use in industries. Now, of course, I'll be focusing on thermal power plants. So what we did was, what I'll do is I'll give you one plant's example, then I'll give you a larger picture of lot many other thermal power plants that we have sort of studied as part of this particular project, and then share with you the kinds of intervention and possible benchmarks. So what we did was, you all are from the power sector, would know that a power generation sector, especially thermal coal-based, coal-fired thermal power plants, they have larger consumption in their cooling system and ash handling system. And many other things as well, township, sundry other uses, auxiliary uses. So what we did was we looked into the entire network of water, right from sourcing to the usage in all of these areas till the discharge point, identified key locations, went on the field, monitored, measured through instrumentation on ground, both the quality and quantity of water, looked into the opportunities, the possible technologies being used, the practices being used. The presentation that I'm giving is just one industry, but the sort of perspective is larger, holistic, from many other experiences from other industries as well. Now, I don't need to basically tell you the process, but since it is sort of discussion in the context, we use steam to generate power, and that steam basically comes in a very close cycle from a boiler, which basically uses water through the DM plant. When we do condensation, the steam has to be condensed, and for that we use cold water. That water is basically by and large used in a closed circulation system, and there are evaporative losses and other drift losses which happens, for which you have to make up the water from the fresh water source. Now that source usually is some kind of river or possibly a combination of river and groundwater, which after taking you treat, and then after treating you use it for your DM plant, you use for your direct makeup to the closed circulation system, to other uses, for example township, as well as ash handling, etc., etc. So largely if you look into the kind of water use, that's the kind of water use that you have in the thermal power generation process. There are other auxiliary uses which as well is part of the entire system. And there would be variation as well within this depending upon the kinds of operation. So as I said, we went into the, many of these power plants, identified locations. I have to thank all the power plants who were part of this study, including NTPC, and I see Kekar Saab over here. Thanks for your support during the study as well. And I'm sure he will be sharing the best practice of dry cooling as well, North Karanpura, I believe. That's the kind of progress that we have made in the sector. But just to kind of share with you, not many such day, night of auditing on ground. It's a very complex process. Just to give you understanding of the water balance, you have 2, 3, 4, 5 stages of any plant, and then you have to each stage you have to go through the entire cycle, identify, measure, and then come to an understanding of the water balance of the entire system. So this is just an example of one of those power plants. We went into monitoring the flow and quality and establishing the water balance. And this is typically what, just for representative discussion, is what it looks like in terms of the water consumption. So large amount of is basically consumed in cooling systems, around 50%. The one that we audited, you'll see variations as well, depending upon the practices. Ash handling around 30%, then others, for example, your township, your firefighting, drinking water, etc. So firefighting is basically sundry use, I would say. It wasn't for firefighting, but largely it's used from the fire hydrant, so yeah, for that as well. Now what you can see is, in this particular plant, we identified that the consumption was around 4.8 to 5 meter cube per megawatt. And what we told to them that you can actually bring it down to around 3 meter cube per megawatt. Now how? Number of interventions. To start with, one of the things that we monitored was to look into the kind of wastewater going down the drain, which was a very significant amount of water. If you can see, around 64,000 meter cube per day, it's a very significant volume. What is also important to note is this particular water is not that bad as compared to other industries. The water that comes from the cooling system is not really that much contaminated. A TDS would be somewhere around 200, 250, 300. Likewise, it can be more as well, depending upon how much recirculation you have done. But this kind of water is quite very well, to treat it with a lesser cost and reuse within the system. And for example, that particular time when we audited, this was going, untreated, basically unused and discharged into the system. Township, many of the power plants, if you are operating, you know that we have a very good township, big township. And one thing that we noted was the water consumption in township was quite high. Again, the numbers vary, but just a representative figure for you. So for example, in this we said you can bring it down from around 1,500 to the norm, which is around 135 LPCD, liters per capita per day. It's not easy. I mean, changing behavioral perspective of human consumption is tough to implement. But if you induce that as a progress, as a system, you can make progress over a period of time, and you can save significant volume of water as well in this particular through this particular intervention. Now, again, I have to rather thank them than basically say anything, because those who have taken audit on themselves, they have to be praised, because unless they would have taken the audits on them, they wouldn't have come to know across these kinds of challenges which were existing in their system. So if you can see an overflow from the cooling system, bursts into the pipe system, water treatment system pipeline, or ash handling pipeline, and I use this just to sensitize the community. And if you can look at the kinds of leakages that we observe, this is not as of now, by the way. They have taken course correction back then only. But this is just to share the kinds of challenges. So, see, the objective of any power plant is basically producing power. So, going into all this wasn't that much of a highlight back then. Of course, it is now. So, it was very good to take an audit on themselves to understand what is my priority area to focus on, whether it is leakage losses, whether it is consumption in A process or B process, or combination of both, or whatever. Now, unless you take an audit, I keep saying this is like a health checkup. Unless you do a health checkup, you wouldn't get to know, well, my, cholesterol is high or my kidney is in problem or, whatever. Where do I need to focus? So that investment needs to be done at a location or at a process where the focus has to be based on the kind of inefficiency or the issue that is identified. And obviously, through entire system, as you can see, we established the water balance, of various kinds of, numbers you can see across the entire process. And back then, this particular plant was back then using around 380,000 meter cube per meter cube of water per day. And through the intervention that we suggested them, it could have been brought down to almost half of that. Recycling, interventions on, cooling systems, increasing the cycle of concentration. I'm coming to that, but this is just to depict to you a possibility on that. I have a policy brief on that as well. A long back it was published. I have a new policy brief as well. I'll share all that with you in some time. But if you can look into the opportunities, by and large, you see that the kinds of opportunities that exist is in the cooling system, ash handling system, as well as recycle and reuse of the wastewater. These are the low-hanging and big-ticket items. The others are there as well. So if you look into the kinds of, ash handling, system recirculation that could be possible was around 80 to 50%, which was the loss into the ash handling system can be basically saved by recirculation, increasing the recirculation of the water, plugging the leakage losses, increasing the cycle of concentration. I believe most of you would know, cycle of concentration is basically the closed cycle, between the cooling system and the, condenser system. And the more number of time you can use this water, the better is the kind of efficiency because you don't need fresh water as for, makeup. And that basically depends on how you are treating the chemicals, how you are maintaining the kind of, solubility of the salts within the water, how you're maintaining the, cooling system, cooling towers, etc., etc. So that was an opportunity as well. Township water, I mentioned, it could be as well reduced in terms of per capita water consumption, recycling, reuse of the treated wastewater. So by and large, with all this intervention, we identified that they could bring it down from, as I said, from around 5 to around 3, and almost around 60% of water consumption reduction, through all of these processes. And we also suggested them a sort of, recycling system, but not going into detail of that. If you can see, the potential that was there for water saving was around, 23% of the intake water. If you want to look into the total intake of fresh water, it was around 60 to 65% saving. And not only that, we looked into the potential cost benefit and, the kind of intervention from recycling and reuse of the wastewater. What we found was that it was having a fair, attractive financial benefit as well as the cost benefit of the system that we suggested was less than 3 years, which is very attractive. Now, I'm not generalizing this, but from all the audits that we have done, we have seen that there is a fair bit of opportunity and most of the interventions are actually cost beneficial. Some of them do have their own disadvantages. I'll come to that in a while. Now, so based on, this was just one example. Now, in this particular study of the benchmarking, we went to many power plants, looked into a lot of available secondary data. Some of them, we audited them as well on ground with different kinds of capacities. And what I'm sharing now is a sort of summary and gist of all of that intervention that we identified and filtered from within those studies. So you know about this now, so I don't have to repeat. For this particular plant, of course, they implemented those interventions. And as you can see, they could already save around 121,000 meter cube per day of water by those interventions, which was suggested as well. It was still being pursued back then. They brought it down from around 4.85 to around 3.21. And this time around, they again called us for audit, and this time around we said, well done, you can now go to 2 again. Now this is a process, that's what I was mentioning as the benchmark. You start from somewhere and you try and reach as closest as possible to the best available benchmark in the sector. Now again, sort of just to reflect to you on the kind of, water saving from various interventions versus the financial saving. Again, this would vary. Please note that we do not have a rational water pricing, so if the water pricing was rational, these cost benefits would have been much better. But just to kind of showcase to you, the kinds of possibilities which are there. Again, these are reflections from various plants that we have audited. Depending upon the kinds of processes and best practice, some of them are really very good in terms of their water use. So you can see they really are consuming not that much amount of water in, for example, ash handling. Some of them have already shifted to dry ash handling. So depending upon the process, the range of consumption is there. And based on that, we also identified what are the kind of, benchmarks that they can basically follow or achievable targets in terms of reducing the water use. So in terms of recommendation, if I have to, bucket it into 2 or 3 major categories, if you look into, I'd start with the ash handling process as well. As I said, 2 major areas, ash handling and, cooling systems, where the water consumption is more. Now, the first thing that I would want to say is that those plants which are already using wet processes, what can be done in them? So if you look into the large low-hanging fruit, I think is to increase the recirculation process. By the way, the range varies significantly. Some of the plants were almost less than 10%. Some of them were already, around 70% of recirculation. So I cannot generalize this as a fixed percentage of, what I recommend. But then most of the plants were not in the range of 70%. So the opportunity lies. So you can increase the recirculation rate from ash dike to the ash handling system and use that water for various purposes like ash and, your own ash handling itself, gardening, firefighting, dust suppression in the coal yard, etc., etc. And again, a significant saving, that could be achieved from that. But then the other option is to move from the, wet ash handling to dry ash handling. And, I'll give you example, NTPC Dadri was already doing that. A few other examples are there. And also switching to high concentration slurry disposal system, there's a system called, high concentration as ash disposal where you maintain a better ash to water ratio. And that can basically significantly reduce the water consumption. So all of these are interventions that can be taken up. They are already being taken up across the world, which can be adopted, and that reduction in water use in the ash handling can be done significantly. Now there are various co-benefits as well. For example, if you are able to switch to dry ash handling altogether, you don't need investment into developing an ash dike, for example, and associated process handling cost and energy handling cost. So all that benefits to you once you move to the system. So by and large, big ticket item, and the various technologies as well, I'll come to that. Hydro bins such as CSD, that as I mentioned. Then of course the cooling system. Now, cooling system, as you all know, is a significant water consuming process of any power plant. So the first thing that I find is increasing the cycle of concentration. The more number of cycle of concentration, the less you need the makeup water. And of course, you can't do it, indefinitely, to any number, infinity, that can't be there. But increasing the cycle of concentration to a level, I have met people who have told me that they have around 10, 12 as well in terms of COC. But what we observed that, the plants that we were auditing, again, there's a fair bit of period and they all have been improving. But just to share with you a range, maybe around less than 2 to around 3, 4, some of them are even 5. But so what we said was, those who are not in that range, they can reach firstly, for example, 1, 2 to around 3, 4, 5 or something like that, and then take it from there in the next phase to higher levels as well. Now that saves a significant volume of water. How that can be done, there are various kinds of ways, and anti-sepsis, for example, maintaining better chemical-based, having the better dissolution of the salts, anti-sludging, anti-sepsis, acidification, all of these are processes through which you can do that. And of course, as I said, O&M of the cooling system as well. So that can save a significant volume of water. And then one can also look into possibility of moving from wet cooling to dry cooling system. Now, obviously, it saves a significant volume of water, almost all the water that you're using for the cooling system when you shift to the dry system. But it has its own advantage and disadvantage. I believe Kekar sir will share with you much more nitty-gritties of that. But usually what we understand is there's a reduction into power generation capacity by I think 5-7% or something like that, and the auxiliary power consumption increases as well, again around 5-7% or something like that. It also requires a first input cost, capital cost as well. So, but that's not a deterrent. In locations where you have a sparsity of water, where the cost of water is already so much that it's either at par or something, you can take this kind of intervention. There are industries which are already doing that. I'll come to that as an example. And then, although most of them have now shifted to closed cycle circulation system in cooling towers or cooling system, but those which are still once through possibly needs to shift to the closed cycle circulation system. Then the third is, of course, the recycle and reuse of wastewater. As I shared with you, this water can be used in various processes within the system, auxiliary uses within the system and township and various other sundry uses. And the treatment is not that difficult. So that's something that we can as well adopt to, moving towards zero discharge. Now, these are the three low-hanging fruits, I would say, which are possibly can save the maximum amount of water as far as thermal power plants is concerned. But there are other observations, it will be worth sharing. For example, rationalizing the township drinking water, plugging the leakage losses where observed. Fire hydrant water, although it's being used for some purpose, but must not be used for any other purpose, because that's something should be maintained and pressurized for the event of fire, not any other process. And then audits must be internalized as corporate water policy, I would say. We have also recommended to the government to make water audits mandatory. I believe that's third-party water audit mandatory. Or let's say at least the realization of this being an important process, I would say will be the first step towards moving towards water use efficiency. And then a lot of opportunities on automation. I mean, a study that we did by use of your SCADA system, and now with all the AI tools, the kind of information management system that you can have can save significant volume of water. Just mere by the timely information of any leakage losses can save you significant volume of water. And what we assessed in one of the studies, especially for the ICT tools, was anywhere between 15 to 30% is what one can achieve by sheer information management system. Now, there are some best practices as well. We can go on detailing that out in more. I mean, there's a publication as well. You can have a look at that. But as I said, dry bottom ash handling, hydrobin-based ash handling is something that is very much, being looked upon as an option. High concentration slurry disposal system, dry cooling, and, looking into the monitoring system improvement through automation. These are all direct approaches that can be adopted. And there are, industries, for example, in Greece, Public Power Corp, they are having both direct and indirect cooling, the dry ash handling. I mean, from wet ash handling, they moved to the dry ash handling. NTPC Dadri is doing that in India. For dry cooling, there's an entity which operates, the Matimba Power Station and Kendal Power Station, both dry and, direct and indirect dry cooling system. And they had the SWC, specific water consumption, of around 0.1 meter cube per megawatt to around 0.08 meter cube per megawatt. So there are best practices, and this is possible is what I wanted to share. And then there are other indirect approaches where you can increase the operating conditions, the steam and pressure, temperature and pressure parameters, and basically the supercritical generation. And then cogeneration processes, for example, integrated gas combined cycle, which is also a possibility to be looked into. I believe NTPC Dadri is doing that, NCPS, and there are others as well as an example. And then, of course, improvement on the technology and retrofitting of systems and replacement wherever needed. So basically, these are the kinds of recommendations that we came up with, short-term and long-term. As I mentioned to you, in short-term, basically ash handling systems, increasing COC and recycling use of wastewater, and long-term, because it requires fair bit of change of system and investment, could be the wet ash handling to dry ash handling, as well as wet cooling to dry cooling system. These are the kind of potential benchmarks we identified from the audit-based information that we had. That this is where the different ranges of power plants can achieve in short-term and long-term. There's a publication which is available. You can have a look at that. Again, we looked into what are the kind of range of water saving as well as potential annual financial saving as well. And as you can see, it's quite attractive to look into. And there's a various kind of range and intervention based on which these ranges are there. But as you can see, a significant volume of water and as well as financial benefit is associated. We recommended in two buckets the recommendation for this particular intervention benchmarking. One was on the technical perspective, something which I have already shared now, so don't want to go into power plant-based details, but something that we also, for example, suggested to the power plants is, as I mentioned earlier, as well as optimizing township, besides the other interventions which are main, I shared earlier. Optimizing township water quality, take regular water audits, have metering and monitoring done on a very extensive network, automated system, do conservation like rainwater harvesting into your watershed, have real-time and automation-based monitoring system, which is very useful. Update the technology. We have seen some of them we've discussed earlier, which can be a very good intervention. In terms of policy, we said that we need to introduce the benchmarks in the water-intensive industries. Recycling and reuse of wastewater needs to be supported from policy perspective as well. So we need to have fit for purpose water quality guidelines, and maybe a fixed percentage or amount to be kind of, given as a target to the various sectors, not only industries, domestic sector as well as other sectors possible, with incentive and disincentive mechanisms. Those who are taking that extra care, extra step, they need to be recognized, encouraged. And then cross-sectoral reuse possibilities, from domestic to the power plants, for example, that guideline is already there. That should be as well done with a little bit more of, last mile connectivity framework clarity. There was a lot of, back and forth between industry and the ULBs that happened, when this was introduced. The sort of guideline for reuse of water from the cities. Who is to bear the cost of the pipeline and so on. So although it's settled now, but I believe we still have not reached that potential which is there. And then of course, institutional monitoring capacity, and the biggest thing I would say, which is still a major bottleneck, is rational water pricing. Not only drinking water or the supply water, but also the wastewater, recycled wastewater costing as well now need to be brought in to make it much more sustainable. So I think I'll stop here. These are the publications which are there, relevant. This is long back that we had come up with the policy brief on the water audits. This is very recent. We have just launched it. All that I shared with you is a fair bit of detail is available. It's available at our website as well. And if you need anything more in detail to understand, please feel free to contact me. I'll stop here. Thank you for your time.